Our planet, a pale blue dot in the vast cosmic ocean, is a stage for celestial ballets of breathtaking beauty and profound scientific importance. Among the most awe-inspiring of these is the solar eclipse, a moment when the moon passes between Earth and the sun, momentarily dimming our star. While total solar eclipses often capture the world's imagination, another, equally fascinating phenomenon awaits us: the annular solar eclipse. And in 2026, one of the most remarkable annular eclipses in recent history will unfold over the most remote and extreme environment on Earth, Antarctica. To truly understand what will happen on December 26, 2026, we must first delve into the intricate mechanics of our solar system. A solar eclipse is a product of a remarkable cosmic coincidence. The sun's diameter is about 400 times larger than the moon's, but it's also about 400 times farther away from Earth. This incredible ratio means that from our perspective, the sun and the moon appear to be almost the exact same size in the sky. However, the moon's orbit around Earth is not a perfect circle, it's an ellipse. This means its distance from us varies. When the moon is at its closest point to Earth, known as perigee, it appears slightly larger in our sky. If it passes in front of the sun during perigee, it can completely block the sun's bright face, or photosphere, creating a total solar eclipse. This reveals the sun's ethereal outer atmosphere, the corona, a stunning halo of plasma that is otherwise invisible. But when the new moon aligns with the sun while it's near its farthest point from Earth, known as apogee, it appears slightly smaller. It isn't quite large enough to cover the entire solar disk. The result is an annular solar eclipse. At the peak of this event, a brilliant blazing ring of fire, or annulus, remains visible around the dark silhouette of the moon. The 2026 Antarctic event is precisely this kind of eclipse. The moon will be too distant in its orbit to create a total eclipse, offering instead this spectacular ring of sunlight. What makes this event so unique is its location. The path of annularity will sweep across the desolate, frozen expanse of West Antarctica, a place synonymous with scientific exploration and extreme conditions. Observing an eclipse from Antarctica presents monumental challenges, but also offers unparalleled scientific opportunities. The continent's high altitude, thin atmosphere, and extremely low humidity create some of the clearest skies on the planet, minimizing atmospheric distortion that can plague astronomical observations elsewhere. This clarity is a boon for solar physicists. During an annular eclipse, we have a unique chance to study the sun's lower atmosphere, the chromosphere. This is a complex, dynamic layer just above the photosphere, a turbulent region of plasma jets and magnetic loops. Normally, the photosphere's overwhelming brightness washes it out. But as the moon's edge grazes the sun's limb during the beginning and end phases of an annular eclipse, a phenomenon known as Bailey's beads occurs. Sunlight streams through the rugged valleys on the lunar limb, creating fleeting points of light. Spectrographs aimed at these beads can produce a flash spectrum of the chromosphere, allowing scientists to analyze its chemical composition, temperature, and density with incredible precision. Furthermore, studying the sun's corona, even during an annular eclipse, remains a key objective. While the full corona is best seen during a total eclipse, advanced instruments called coronagraphs can be used to block the bright ring of the annulus. By doing so from the pristine Antarctic environment, we can obtain high-contrast images of the inner corona, studying its intricate structures and how they are shaped by the sun's powerful magnetic field. This is crucial for understanding space weather, the stream of charged particles and radiation from the sun that can impact satellites, power grids, and even astronauts in space. The technology required for such an expedition is at the cutting edge of science. Teams will deploy portable, high-resolution telescopes equipped with specialized filters to safely observe the sun's intense light. Hydrogen alpha filters, for instance, isolate a specific wavelength of light, revealing dramatic features on the sun's surface, like solar flares and prominences, huge arcs of plasma extending into the corona. Polarimetric instruments will measure the polarization of light from the corona, providing insights into the three-dimensional structure of its magnetic fields. Beyond solar physics, the eclipse offers a chance to test Einstein's theory of general relativity. According to Einstein, the immense gravity of the Sun warps the fabric of space-time around it. This causes light from distant stars passing near the Sun to bend. During an eclipse, when the Sun's glare is diminished, astronomers can precisely measure the positions of stars near the solar limb and compare them to their known positions. Any shift confirms the gravitational lensing effect predicted by relativity. Performing this experiment from Antarctica, with its stable atmospheric conditions, could yield some of the most accurate measurements to date. The logistical undertaking of a scientific expedition to observe the 2026 eclipse is immense. Scientists and their equipment must be transported to remote field camps on the Antarctic plateau, where temperatures can plummet far below freezing, even in the austral summer. They will rely on ski-equipped aircraft and traverse vehicles to reach the optimal viewing locations within the narrow path of annularity. These temporary observatories must be self-sufficient, capable of withstanding harsh winds and extreme cold, all while powering sensitive scientific instruments. This event is more than just a beautiful spectacle, it is a natural laboratory. It's an opportunity to probe the fundamental workings of our star, to test the laws of physics in a unique setting, and to push the boundaries of human exploration. The data gathered from those precious few minutes of the ring of fire over the ice will fuel scientific discovery for years to come, deepening our understanding of the Sun's influence on our solar system. As the lunar shadow races across the white desert of Antarctica on December 26, 2026, it will connect the celestial dance of the Sun and Moon with the most terrestrial of extremes. For the scientists braving the cold, it will be a moment of profound discovery. For the rest of us, it is a powerful reminder of the intricate and beautiful universe we inhabit, a universe that continues to reveal its secrets to those who dare to look. This Antarctic Ring of Fire will be a landmark event in the history of astronomy, a testament to our relentless quest for knowledge and a celestial spectacle for the ages. Thank you for joining us on this journey to the bottom of the world for a glimpse of a cosmic masterpiece. If you're fascinated by the wonders of our universe, make sure to subscribe for more deep dives into science and exploration.